Hello, Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Ahmad AMIRUL bin JAHARUDDIN, my metric number 20056, and today I would like to introduce to our project. From our project, we have gas power plant. Natural gas power plant come in a variety of shapes and sizes, all of which create electricity but serve specific implications. All natural gas plant use a gas turbine. Natural gas is added, along with a stream of air which combusts and expands through this turbine, causing a generator to spin a magnet, making electricity. There is waste heat that comes from this process because of the second law of thermodynamics. Natural gas power plants are both inexpensive and quick to construct. Second, we have vapor power plant. The steam power plant can operate as thermal power plants where chemical energy of fossil fuel like coal, oil and gas is released into heat by combustion to raise steam. Geothermal power plant where springs of hot water or steam from the interior earth can be directly used to turn a turbine. Hot water from the sea surface can be used to power a power plant in ocean thermal power plant. Lastly, we have combined power plant. Combined cycle gas plants are type of natural gas power plant used to generate electricity, consisting of a simple gas cycle plant in combination with a second steam engine that uses the Rankine cycle. The efficiency of these plants can be as great as 55%, but the dispatch time tends to be slower than simple cycle natural power plants.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is MUSTAQIM bin Muhammad NAZRI, and today I will present to you about our project's slide. I will present about gas power plant. So as you can see, the gas power plant is using a Brayton cycle. Okay, this is the diagram of Brayton cycle. The Brayton cycle is a thermodynamic cycle that describes how gas turbines operate. The idea behind the Brayton cycle is to extract energy from flowing air and fuel to generate usable work which can be used to power many vehicles by giving them thrust. So as you can see in the diagram, the air is compressed in the turbine compressor. The air is then mixed with fuel, which in this situation we use coal as our fuel, and burned under constant pressure conditions in the combustor. The resulting hot gas is allowed to expand and spins the blade through a turbine to perform work which connected to a generator, and it generates power, which means electricity. So this is the gas power plant PV and TS diagram. So as you can see, this is the shape of the diagram. The combustion process is replaced by a constant pressure heat addition process from an external source, and the exhaust process is replaced by a constant pressure heat rejection process to the ambient air. As you remember the diagram before, the 1 to 2 isentropic compression happen in a compressor, 2 to 3 constant pressure heat addition, 3 to 4 isentropic expansion happen in the turbine, and 4 to 1 constant pressure heat rejection. So this is the advantage and disadvantage of the gas power plant. So the advantage are the gas power plant is have a low operating and maintenance cost. So the next one is it is much smaller compared to vapor power station of same capacity. So which means it is simple. And next is the less water use since there is no need for a condenser. So we don't need to use water for this power plant. And the disadvantage of gas power plant is overall efficiency of plant is low, which is 20% approximately, because of exhaust gas still containing heat, only efficient in the combined cycle configuration. So it needs to be complex to achieve higher overall efficiency. And next, the disadvantage is net output is low since greater power is used to drive a compressor. And lastly, the temperature of combustion chamber is too high, thus resulting in a lower life. so it's not reliable. Okay, so that's all from me. Thank you.
Vapor power plant. Vapor power plant has two cycles, which is Rankine cycle and Carnot cycle. And we choose Rankine cycle. Okay, this is diagram of Rankine cycle. First, the fluid will go into the pump and will be compressed. And then the fluid will go to the boiler. And the fluid will be heated to the final temperature, which is what we call as boiling point. And then when the fluid at the boiling point, it will change the phase into the vapor, and the vapor will go to the turbine, and turbine will produce the output. And then the wasted heat will go to the condenser, and condenser will bring the waste heat into the final heat sink, which is lake or river. And that's all complete diagram of Rankine cycle. And then we go to the PV and TS diagram. First, Rankine cycle efficiency is higher than Carnot cycle. Its efficiency much higher because Rankine cycle using a pump to compress the fluid to become high pressure fluid. Okay, we go to the diagram. Okay, we can see process 4 to 1 is saturated water is isothermally convert to the dry saturated steam. And for the process 1 to 2 is the steam expand isentropically, and the pressure and temperature will fall down. And then the process 2 and 3 is the wet steam enter to the condenser for condensation of steam. And then the last process is 3 to 4, which is water will enter to the boiler at a point 4 position to warming, or what we call heating the water into the constant temperature. And on the constant temperature we will get the vapor. The water or the fluid will become vapor phase, and then the vapor will go to the turbine and we will get the output. Okay, for advantage and disadvantage. Advantage, Rankine cycle has higher thermal efficiency, and it also improve the thermal efficiency. And Rankine cycle has less handling of fuel and firing requirement. And the disadvantage of Rankine cycle, it generate less power than steam cycle, so it's below than steam cycle. And it also cost will be higher for a specific application. And then the last one, it can occur environmental hazard when in the system of Rankine cycle have a leakage. And that's all from vapor power plant. Thank you.
Assalamualaikum and hi. My name is AMIR bin FADILAH. My matric ID is MA19124. And I am going to be explaining and presenting about the combined vapor gas power plant. To start off, I am going to show you a diagram or figure of the combined vapor and gas power plant. As shown here, there are a couple of elements and things that are involved in this power plant. Firstly, there is the air compressor, the combustion chamber, cooling air, gas turbine, stack, heat recovery, steam generator, steam turbine, turbo generator, condenser, pump, and also cooling tower. Here, it is showed all the lines that represent each of the components respectively. Next, this is also another figure showing and to explain more about the given power plant. Here, there is the compressor, combustor, turbine, gas turbine, air inlet, exhaust, heat recovery steam generator, pump, condenser, turbine. Also, here is where the gas comes out, which is from the turbine, and at the bottom here is where the vapor comes out. And there is also cooling water that comes in. Moving on to the thermal efficiency. Here, we have already calculated the thermal efficiency and the working is as shown. The work is 50 megawatts and equals to 0.45. The heat required is 111.11 kilowatts. The end of the Rankine cycle is 45%. Then the amount of steam required is 1.70 kg per second. The end of vapor gas turbine can be calculated as shown here, which is the W vapor plus W gas divided by Q in. Then at the end would be equal to 0.45. Then the required coal. The required coal to provide the heat source is calculated here, and the answer is 3.79 kg per second. That is all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin ZULKIFLI. My matric ID is MA19141. Okay. For today, I will explain about combined vapor gas power plant. I will explain the topic about TS and the PV diagram of the power plant, and also the advantages and the disadvantages of the power plant. So as you can see, this is the TS and the PV diagram of the combined vapor gas power plant. The diagram is basically same like the vapor power plant and also the gas power plant, which is, as you can see at the top left and the right side, is this is the TS of diagram of the gas power plant, and also this is the PV diagram of the gas power plant. And at the bottom side, this is the vapor power plant TS diagram, and this is the vapor power plant PV diagram. The properties are all the same, but the difference is only it's combined. Next is the advantages and the disadvantages of the combined vapor gas power plant. The advantages is first is high overall plant efficiency. The efficiencies exceeding 50% can be attained. After that, low investment cost, because 3 of the output is produced in a GT and only 1/3 in the simple ST. The investment costs required are approximately 30% less than those for a conventional steam power plant. After that, small amount of water are required for this power plant. The amount of cooling water required for this power plant is only about 40 to 50% as much as for a steam power plant. Lastly, great operating flexibility. The simple steam cycle make it possible to start up and shut down the plant quickly, which also affect efficiency in a positive direction, reducing startup losses. The advantages of this power plant is it is not suitable for all sites, so that it is financially intensive. Hence, it requires a lot startup time. And lastly, it should be operated in an ongoing basis rather being cycle on and off. Okay, that's all for me. Thank you.
And for the conclusion, from the above topic, we conclude that gas turbine plants possess inherent advantage of simplicity and flexibility of design and installation. We witness the many procedural processes and equipment used in the creation of electricity by thermal power. which had previously been covered in book, and this has helped us gain a better grasp of power generation and concept of instrumentation. Gas turbine system also require much less water than steam power plant, and they are easily converted into combined cycle power plant, which are much more efficient. All of the machine and equipment required to use coal to be a staple fuel for power plant generation. Future technology scientists and engineers are educated about coal-fired power plant. The usage of coal may become environmentally tolerable in the future, and innovation beyond today's typical coal-fired power plant may emerge.